Hello everyone, my name is Jérôme Le and I am the head of research at École des Ponts et Chaussées. Welcome to École des Ponts et Chaussées, which means literally School of Bridges and Pavements. That's pretty cool and modern, I think. As the oldest engineering school in France and maybe one of the oldest in Europe, we still educate students to civil engineering, of course, and we do research as well. But today, we do a lot more. We talk about mathematics, mechanics, climate sciences, environmental sciences, but also economics, history, geography, and many other things related to social science.
In 2018, École des Ponts joined the Science 2024 project. It's a collective research program involving engineer schools and fundamental science that is dedicated to solve questions identified with athletes and their coaches to support them in their quest for medals at the Paris 2024 Olympic Games. At École des Ponts, we have a project in different sports. We have a project on pole vaulting, we have a project on archery. But today, in this presentation, we're going to be focusing on four sports. We're going to have a discussion about soccer and the fairness in tournaments. We're going to also have a presentation that I'm going to do on competitive swimming races, and also a presentation about racing conditions for open water swimming. For this discussion, I have three other speakers with me that I'm glad to introduce. We have Brigitte Vinçon-Leite, who is a researcher at École des Ponts at the LEESU Laboratoire. Her research area is environmental engineering and urban hydrology, and she works on high-frequency monitoring and modeling of water quality in urban water courses. The third speaker is going to be Arthur Guillot-Le, who is a PhD student of Brigitte and myself, and is working on hydrodynamic modeling and microbial water quality in urban water bodies. And our last speaker is Julien Guyon, who is a professor of applied mathematics at École des Ponts, and his research interests are volatility and correlation modeling, option pricing and numerical probabilistic method, but today he's going to be talking about fairness in tournaments, mostly soccer, because he's a soccer fan, but this research could be applied to other sports, as we saw in the previous classification. And most precisely about a project we have on Olympic swimming starts. This project is part of a larger project. It's called the Neptune project. It's a project financed by the Research National Agency of France. So what you can see is that the American swimmer Jones exit the water about 9 meters after the start, while Florent Manodou, who won the race, exit the water really close to the end of the official limits of 15 meters. The American Jones finished second, which is not a bad result, so we'll be also happy with silver medals in Paris. So you can see that even at this level, it's the top swimmers. We can see really different strategies. And one of the goal of the project we have on competitive swimming start is to help the athletes take the most of these 15 meters and optimize this part of the race. And you can see that the answer is no, you don't have to do 50 meters underwater to be the fastest. It really depends on your characteristics. So to do that, what we ask the swimmers at INSEP is to actually do first a start where we extend the gliding phase just to be able to measure the resistance. So you can play the video. So here is the exercise we do. And we also ask them to just do a standing start, but only doing dolphin kicks underwater. And what we can see from those kind of tests, through measurements, is that the swimmers has less resistance during the passive glide, but there's no propulsion, so the velocity is doomed to decrease. But during the dolphin kicks, the swimmers has high resistance, but has propulsion, so it's going to reach an asymptotic velocity.
We will continue with Olympic Games and swimming, but two events in the Olympic Games and Paralympic Games will be in the River Seine, so in open water swimming, And it is a specific aspect we are working on at École des Ponts, is also the legacy of these events of swimming in the river, in urban rivers, after the Olympic Games. And it is well recognized since the 19th century that contamination of rivers by sewage can occur after a rainfall event, and they are the cause of enteric diseases. So, as I already said, it occurs principally after heavy rainfall episodes where the stormwater networks, their capacity is exceeded and stormwater overflows. So, in preparation to the Olympic Games, many sanitation works have been done during the last 5 years, and they are now completed, recently completed. So you can see on the map 2 main wastewater treatment plants, upstream Paris. This is this type of method based on fluorescence of dissolved organic matter. We are working here at École des Ponts within an European project funded by the Eurostar program. And so it is based on the detection of protein-like components of the bacteria, of the indicator bacteria, through their fluorescence signature.
Then we can represent the flow of the river to know the transfer time of bacteria, its spatial distribution, to estimate when a bathing threshold could be crossed and for how long. This idea is being tested at La Villette, which is in the north of Paris, where an urban bathing site was reopened in 2017. This is the first urban bathing site that reopened in Paris since 1923, when bathing in open waters in the Parisian region was forbidden. Video that start now, that start on the 13th, we can see at the beginning that it was all green, so the water quality was acceptable for swimming on the 13th of July. Then there is a first peak that happened 12 hours later, and the bathing area is beginning to be contaminated. Then there is a second peak that happened on the 16th, and the bathing area remained contaminated until the 18th in the morning. In the case of a short-term prevision, with a monitoring system Paris installed upstream, and hydraulic models that run for 15 minutes, we are able to forecast the water quality at the bathing area nearly 12 hours later.
So how does it work? You have 32 teams who qualify for the World Cup, and then they're divided into 8 groups of 4 teams. Okay? And so you're going to learn at this moment, you know, who you're going to play, who will be your opponent, and what are your chances of advancing. And so the draw takes place, and immediately I realized that something is really wrong, because you ended up with like, okay, 8 groups of 4, 3 of them very strong, and 4 of them very weak. So I had a lot of time to think about this problem, and it took me, in the end, like maybe 2 months actually to get with like a very satisfactory mathematical answer, actually 3 propositions. And actually, so long story short, the first proposition was actually adopted by FIFA 4 years later for the 2018 World Cup. So all the proposals are, you know, based on that very simple idea that the 4 pots should really be by level. See examples of draws using the actual FIFA draw, and on the right-hand side that would be following the rule that I suggested at the time. Okay, and so when you see like the very strong group, you see they are like very red, and the very weak group they are very green. Okay, and so if you actually click on simulate draw, Mustafa, you can see like plenty. You can do it like several times, and you will see that globally it's going to be on the left that you will see like a lot of colors, right? So very strong groups and very weak groups, just because yes, there is no, the right-hand side, so the new method guarantees balance, but not at the expense of the geographic constraint. Right? The geographic constraint is satisfied both on the left and the right-hand side.
An innovation talk like today, these talks are both a way to exchange between us about education and research, but also a showcase of the vitality and excellence of our work together.